Good morning, good afternoon, good evening, wherever any of you are. Thank you all for being here today. I am Elliot Crow, and I'm very happy to welcome you to today's webinar. Before we dive into the weeds, I am very happy to introduce David Nemtso, Director of the U.S. Department of Energy's Building Technologies Office, who is going to be kicking off the proceedings today. Over to you, David.
Great. Thanks very much, Elliot. And thank you all for being here today and whatever time zone you are. Today, of course, is our annual Smart Energy Analytics Campaign recognition ceremony. And we wish we were all together in person, but 2020 being what it is, here we are. And so with our colleagues at Lawrence Berkeley National Lab and the Better Buildings Program of the U.S. Department of Energy and the Building Technologies Office, we welcome you and we honor our Smart Energy Analytics partners. So this is our third year of campaign recognition for best practices and outstanding analytics projects. This is a public-private partnership, I think you all know that, in which we share best practices, we share what works, what doesn't, how you solve problems, and as well as, of course, uptake and costs and performance. And that helps each other, it helps others with voluntary take-up of best practices in smart energy analytics. So we initially started this when we started in 2016. We were anticipating a DOE, maybe some 80 businesses or more. By last year, we had already had commitments from 104 businesses, and most of whom are portfolio owners. So it works out to a total of 530 million square feet of commercial floor space that's covered among over 6,000 buildings of our 104 partners. So that's been very exciting, and we're very glad to exceed expectations, and that's because of you all. So that covers all sorts of sectors: retail, healthcare, hospitality, lodging, office space, public buildings, etc. And typically we think about energy management information software and services for buildings that are greater than 100,000 square feet. Warehouses are a little different. And so that total sector in this country is 30 billion square feet of commercial floor space. So we thank the partners we have, and we recognize the work that's still in front of us to get the word out and to get others to adopt the smart and productive and cost-effective policies that you have in your companies. And the savings are there. And this isn't one of these things like, I don't know, pick some extreme example, photovoltaic panels where you cover a roof with PV and it produces clean energy, but at a capital expenditure. And it's not even like building a new zero net energy building, which is very exciting, but again requires sometimes radical changes and sometimes capital expenditures. This is about doing things on the cheap, being able to use smart analytics to change operations, to use software, to use existing technology, as well as maybe some new ones, and being able to save 4 to 9% of energy use. And that's very significant, considering that you can do it typically without significant capital expenditure at all, but just by being smarter and clever about how your building is performing. Just recall, I'm going to expand beyond just that subset of the commercial market we targeted, but as a whole in our nation, both commercial and residential, the 125 million buildings in the full building sector spends over $410 billion per annum in energy, heating, cooling, lighting, etc. Over $400 billion, and we know at least a quarter of that is wasted. So just by smart energy analytics alone, we're looking at 4 to 9% savings. So you can't translate that across that whole building stock, but you can see we're talking about tens of billions of savings annually, and that means better economic competitiveness. And look, in these days, I don't have to tell you, your companies and your organizations are hurting. The whole nation is hurting economically, and it's worth taking a moment to think about the recession that we're in and the crushing unemployment. And some people say, well, we don't have the luxury of worrying about energy, but it's just the opposite. We don't have the luxury of not worrying about energy, to save money and to be able to use that money to keep companies afloat and nonprofits afloat and put people back to work as we think about this current recession. So that's what smart energy analytics is about. That's what our other work in the Department of Energy and Better Buildings and the Building Technologies is about. And so you all are a model for that. And we thank you. And we thank you for your work. Of course, as always, we thank you for the work you're going to do in the future as you continue to spread your smart analytics throughout your own companies, to the rest of your portfolio, and to your colleagues. With that said, I'm going to turn it back to our moderator, Elliot. Thank you.
Thanks very much, David. You know, really important, you know, for us, we love to get into the technical weeds with because of this technology, of course, but it's great to hear from someone like yourself about the real big picture impacts of these efforts. So yeah, it's certainly great to be reminded of that. So as mentioned, I am Elliot Crow, and on this slide here, we see the rest of the wonderful team here at Berkeley Lab. This is our final round of awards, and it's been so great to be able to share the successful implementation of analytics through these kind of awards and the storytelling we can do. Now, before we get to the awards, I do have a few quick announcements. I'll get through as quick as I can here. Number one, if you haven't already registered for some of the virtual sessions at DOE's Better Buildings Summit, get yourself over to their website after this webinar to check it out. Last year was my first year visiting that event, and it really was a fantastic way to network and meet and really learn what's happening out there among the smart buildings community. And the virtual format makes it easy to attend all the sessions you want from wherever you want, with whatever kids and pets in the background you want. Next up, a shout out for an upcoming Better Buildings technical team call in July. And this is a really hot topic. You're going to hear from building owners and operators who are members of the Better Buildings Alliance Buildings to Grid Working Group. They're going to be describing how they optimize performance of renewables and storage for load flexibility, which I know is a really hot topic. It's not yet on the Better Buildings calendar, but look out for that very soon, and that's a chance to look at the other events that are going on at Better Buildings. Next up, a few words about the Smart Energy Analytics campaign. There's a little bit of overlap here with what David said, but I think it really bears repeating that the campaign was a very ambitious undertaking back in 2016. Other DOE partnership campaigns did exist, but most of them were about supporting unit replacements with efficient units, whereas EMIS, as all of you know, is very process-oriented and required us to engage for multiple years with the participants to really track and monitor their progress over time. Now, back in 2016, the technical capabilities of EMIS had been demonstrated. There were some case studies, but we really lacked a broad understanding of diversity and just how these technologies were being installed and operated. And information on costs and benefits was also sorely lacking. Now, if we fast forward 4 years, the campaign partnered with 104 organizations, and we got some big numbers here. David mentioned these, I won't repeat them, but some big numbers that represent how the campaign has engaged with the market. And we've learned a whole lot from all of these participants, gained valuable market data, and we surely hope we've helped them along the way with some technical assistance. Now, if we look specifically at the award winners over the 4 years of the campaign, I'd like to give kudos to all of these organizations and those that will be presenting here today. We've developed many success stories that document the accomplishments of these organizations, and you'll see the header here has their web address if you want to go and check out those success stories. Anyone in the buildings industry knows that case studies and stories from your peers are so powerful. We really think this is a real plus to have all these stories for the campaign. Keeping things moving here, I just want to also mention that the Better Buildings Alliance EMIS technical team, the campaign is going to be sunsetting this summer. So for anyone who's in the campaign currently, please go check out the Better Buildings Alliance EMIS technical team. They host webinars, provide resources. It's a place to share your work with your peers and learn from your peers. And all those webinars are open to the public. So there's no commitment, but certainly look to get yourself on the list, and we'll keep you updated of any events that are happening there. All right, so now to the main event. We have a great group of organizations being recognized in this webinar today by the campaign, and there's so much to learn from this group. I will introduce each of the awardees, say a little bit about why they received their award, and they will be giving you a bit more of a deeper dive into what they're doing, some storytelling, some color commentary. At the end, after we've had all 4 of the presentations, we'll have some time for Q&A, but feel free to send us any questions you have along the way, and we'll try and get those covered by the end here. So without further ado, I'd like to introduce Jessica Loper and Austin Upton and Gary Walters of Commonwealth Partners. Commonwealth Partners are being recognized today for best practices using an EMIS, and the kind of things that really stuck out to us in the work that they're doing. In terms of best practices, they have an engineering team daily review of their EMIS looking for anomalies and peak demand. They use portfolio level dashboards to help prioritize across their large portfolio and to drill down as needed where they see anomalies or issues. And they're also tracking projects to make sure that they can close the loop and make sure they're actually going to get the savings that they expected and track those trends over time. I think closing the loop is obviously a really key part of improving operations and maintaining operations. And with that, I will hand you off to the Commonwealth Partners team.
Thank you, Elliot. So you've got, yes, Austin here with Commonwealth. I help oversee operations for our portfolio. And just a little background about the product we use. So what we use is a product called AquaCore. It integrates, as I'm sure many of you have heard of it before. It puts meters at each of our buildings and some integrated directly into the BMS so that we can see real live power consumption at any building at any moment in time, trend it, compare it to our peers, and really help get a grip on where our buildings are at, where our opportunities are for improvement. We started implementing this in 2018. And the most important part is really that it's a tool for our engineers to monitor their buildings and be empowered to look for anomalies, problems, and opportunities for improvement. And then from a corporate ownership side, we're able to see, keep tabs and make sure everyone is up to speed and doing what they're supposed to. So from a portfolio level, there's a million and one ways where we can look at individual buildings and compare them side by side. And all this data can be automatically weather normalized, climate normalized, and compared to peers, which is what you can see here. And it's became particularly powerful recently with COVID-19 and the mass exodus from our dense buildings. So we'll touch more on that towards the end. But it's been a great tool for oversight. So looking at the next slide here.
Use of vehicle was checked.
Can we hop to the next slide?
Oh yeah. Okay.
Perfect. Thank you. So yes, as I mentioned, we have the opportunity for engineers to do daily checks and have automatic reports sent to them, emailed to them, so that as they get up in the morning, come into the office, that they can look for trends from the previous day, from the previous week, and they'll sometimes spot things. What we see here is, you'll notice in the lower right portion of this graph, is a really jagged energy curve, which is not typical of what you would expect late at night. And what it was a chiller cycling on and off, and we had lost our primary off-hours chiller. And so just by seeing the energy consumption, we were able to see that. So in a modern building, we have alerts from a BMS, but not all buildings have that, and not all can right away highlight what's going on. They might be giving us troubles or alerts, but we don't know what's happening. But by seeing what the energy consumption is doing, we can see that something is happening, and dive right into that to see what questions there are. And I did see one question. The platform we're using is AquaCore, is what it's called. So moving forward to the next slide here. The next kind of phase, so we started this really as all just oversight and monitoring. The next phase we've moved into is a new product through AquaCore called HVAC Analytics, and it uses artificial intelligence. So I will say we're still very early in testing this out. We started in January at 560 Mission in San Francisco. But what it does is it integrates, on top of just the meters, it integrates into the building BMS and can trend all equipment and performance of that equipment, air handler set points, chilled water temperature, and what pieces of equipment are running, and then makes recommendations on how we can better improve our operations. And these are human reviewed recommendations, and it pops up in a project list for the engineering team to look at, what is this? And sometimes there's an explanation. There's maintenance going on, there's a known problem, but it highlights new issues or new opportunities for adjusting our sequence of operations to increase efficiency. So we're still early in the testing phase, and we intentionally put it at one of our most efficient buildings to kind of give it the greatest challenge to see if there's benefit in it, but so far it's promising. And one example of a project, if we take a look at the next slide, what you can do is really easily hone in on comparing individual pieces of equipment. So you can pick two identical air handlers, run their trends side by side, and what we can see here is that you notice one air handler, and these are two identical pieces of equipment, is routinely running a much slower discharge temperature. So what's driving that? And I think what we found there was that there was one zone where there was a thermostat behind a printer, if I recall correctly, and it was artificially being heated up, and the whole air handler was trying to ramp down to serve this one zone that was not actually as warm as it thought it was. And with short of a occupant complaining of a comfort issue, you really wouldn't see that, but you would see it in the energy consumption, and that we're having to ramp our energy consumption up to cool and provide that lower discharge temperature that just one zone on a whole floor of an office needs, and in actuality doesn't need, because these are two identical floors that should have really similar needs. So this was a great recommendation. The engineering team was able to quickly dive into it and figure it out. So we'll continue to monitor that in the coming year. And then moving on to the next slide, one other kind of interesting, very topical and relevant tool where AquaCore was very valuable to us has been recently with the coronavirus pandemic. As I'm sure many of you have experienced, your buildings are empty or nearly empty, and tenants are going to be expecting savings at the end of the year when we reconcile our operating expenses. And so what AquaCore started doing was providing us weekly graphs of, a baseline week of roughly March 12th to 17th, when people really started to leave buildings, and how we were doing on our energy consumption. And what we found at our single largest property here in Los Angeles, that right off the bat, we were a little slow in driving energy savings. And so after further follow-up with the team and adjusting parameters in our startup procedures, pushing that back, putting all the blinds down, a simple change, we were able to surge past other buildings in the market, which was great to see. And it was great to have that benchmark of comparing ourselves to our peers in the market. And just at this single property alone here in downtown Los Angeles, we've saved over $300,000 in the past 6 weeks since the coronavirus outbreak, which, certainly a diligent engineering team would have driven a lot of those savings. But if we hadn't had that oversight to see that we were behind some of our peers and behind even our other buildings, we were able to really dive in and go, okay, what can we do how do we strategize best to really drive down this consumption and our bill at the end of the month. And so that's been a great tool to compare and help us on an oversight, and it also helps us answer questions back to our tenants who they assume when the building is closed, there's no power going to it. We all know that that's not true, but it gives us benchmarking to our peers so that we can say, you know, not only are we making a lot of energy saving efforts, we're right in it with our peers or even ahead of them in many cases, and it really will defend us in an audit at the end of the year or any kind of ongoing questions tenants may have. And we can, I think, move on to the last slide here. I don't know if there's one more after this. So we move on to the
that was the final slide.
Yeah, so I think that's just a high level overview of the AquaCore platform and how we've implemented it. And as we move on towards the end, I think we'll take questions, and so we want to hear about how we keep everyone engaged and using it.
Wonderful. Well, thanks so much for that. Appreciate the presentation. Next up, we're going to be moving on to recognize the largest portfolio using an EIS within the campaign right now, and that goes to Stony Brook University. Very pleased to introduce Tom Lanzalotta, who's going to be presenting here in just a moment. And just a few words here on some of the things that we saw in their application and what stood out in terms of recognition. They took a very customized approach to their EIS installation. They created their own dashboards. They have an annual building energy report to track ongoing trends. They're really on the lookout for alerts for high energy use and peak demand, which I know is an ever increasing topic. You know, more areas of the country that peak demand is growing in importance. And focusing on unoccupied hours, I think we all know that there's so much potential there, so many controls related issues or equipment issues or operator related manual overrides, etc., that impact unoccupied hours. And I think in the context of EMIS generally, it always helps to think about what is your goal, what is your focus, and use the tool to support that goal and that focus. It's very easy to get overwhelmed with all this technology and all this data, but if you actually have a specific focus, then it really helps you crystallize and align your team around that with this new tool that you have. So I'm looking forward here to hearing from Tom a little bit more about what they're doing at Stony Brook University. Over to you, Tom.
All right, thank you, Elliot. And thank you to the Smart Energy Analytics team for recognizing Stony Brook University as an award winner. And I want to congratulate all the awardees. So university is quite large, as Elliot mentioned. We have 211 buildings. It's over 12 million gross square feet, a lot of acreage, all different types of buildings. We have dining facilities, a hospital, laboratories. We have a veterans home, dormitories, data centers, you name it. We're pretty much a small city. So it's a lot of buildings to monitor. So we had to come up with a quick and easy way to analyze those buildings. Next slide, please. So it started in 2012, and we started with 50 metered points. We're now above 370. So what we're looking at electric, high temperature hot water, chilled water, domestic water, and we have some asset level meters. We actually have some gas meters in there now. So there's, like I said, a massive amount of data coming into a centralized server being collected every 15 minutes. So we really needed a quick and easy way to spot anomalies. Next slide, please. So what we did, we came up with creating our own energy intensity heat map. What you see here is on your x-axis, you have the time of the day, and then y, you have the month. So green is good. We like to see green. And this is sort of a typical office type of building where you see green early in the morning. The building becomes occupied, so it changes to a red color, which is more energy intense, and then back down to green when everybody goes home and the building becomes unoccupied. You see the weekends are green, which is something you want to see, and Fridays look like everyone's leaving a little bit early. So next slide, please. So we started out with that energy intensity heat map, and as another phase, we continued and we looked at other ways to view the data. So we're now doing that with a calendar view, which is on your left-hand side. And then we also brought in class schedule data. So I'm fortunate enough to have a really, really smart assistant that was able to program all of this data in Google Sheets. So the energy intensity heat map, this calendar view, class schedule view, it pulls energy data from that centralized server that I was talking about and displays it for us. So we can easily spot anomalies. The great thing about that class schedule view is that it's nice because if the building opens up at 8, you can see on the right-hand side with the class schedule view, building opens, it opens earlier, but the classes aren't starting till 8 o'clock in the morning. So if we're opening up, we're putting the building into occupied at say 5 in the morning and the classes don't start till 8, well, there's some opportunity there. Same thing at the end of the day. If we're running this till 10 o'clock at night and the classes end at say 7, 8, 8:30, we have opportunity to squeeze that occupied, unoccupied schedule. And sometimes by looking at this calendar view as well, it's probably one of my favorite things. Actually, just looking at the calendar view, you could see how the building is operating. We know all the Sundays is going off, Saturdays were going off, and then Monday through Friday, you could see a similar hump for each of those days. Next slide, please. So with all these buildings that we have in our system, it's almost impossible for 2 people to go through every single one every day. So what we did was we baselined the buildings. We said, hey, at 2 o'clock in the morning, you're supposed to consume figure 30 kW. If we see a spike, if it goes above that threshold by a certain amount, we want to be notified right away. So what we did was we programmed that in there, and now if the building goes out of range, just a lot of times our maintenance team might be working on it. They put things occupied 24/7 and then forget to put it back into place. So now we get these triggers right away and we say, hey, what's going on? I would talk to the HVAC department and then we would put things back to normal. The other thing that this catches, actually, we've had issues with rooftop units that were not commissioned properly. So we caught that, changed it, and we saved a lot of money doing so. Same thing, we also do get peak kW notifications. So this actually happens quite often with our data center. Keep on adding equipment. We have a threshold that we programmed in and it goes above that threshold, so we get that email notification. And usually there's not much we could do, but we are notified. Next slide, please. The other thing that we use this for, we have a lot of energy projects going on. So we use this to ensure that the energy projects are saving as much as they say they're supposed to. In this case here, this was a building that that blue chart in the front was 2018, and we put a project through in 2019. In the back, you could see that the energy is a little bit higher. So we questioned this, and problem was the system we put in was not programmed correctly. So once we fixed that, you could see in late June, July, and August, the numbers, the energy really started to come down. Some of the other things that we do use it for outside of M&V, we baseline buildings, we could right size equipment, we can confirm, like I mentioned before, that the equipment is running properly. Maintenance issues, actually with COVID and all these buildings being unoccupied, we benchmarked baseline per square foot. We can notice when buildings are a lot higher than they should be. One of the buildings we noticed had hot water valves that were passing. So it's a good conversation piece to go to our HVAC department, and they could schedule those to be fixed. Next slide, please. So for the future, what we're looking to do is take data from our building management system, energy management system, class schedules, pull in building occupancy and weather data to a centralized server, and have a fault detection diagnostics and analytics program installed. But we can't really do that just yet until we have that server in place. So really that's kind of where we're looking to go, and there's a lot of potential for more savings once we do that. And I think that's the last one, Elliot.
Wonderful. Thanks very much, Tom. Just a quick word for anybody in the crowd here. Please keep sending us your questions. For those who've sent them in, great. Others, please get them in. We never have enough time for them. I just want to reflect on what we've seen just in these two presentations, just things like how the technology is really being employed within the processes in the organizations, and that really is key to success. We've seen two contrasting examples of how it's used, but really it's all about fitting the processes around the tools and vice versa. And really, you know, when you think of all the different types of benefits you can get, right-sizing equipment, project M&V, commissioning new installations, I think it's really great to see these examples. It's not just a single tool with a single set of functionality. It really evolves, and something like the COVID pandemic comes along, and all of a sudden you've got this extra way of dealing with the issues that brings up. So yeah, wonderful examples we're seeing here today. And let's move on to see some more. So next up, we have the recognition for new installation of fault detection and diagnostics technology. This goes to University of Utah Health. Very happy to introduce Robert Armstrong, Energy and Sustainability Coordinator for University of Utah Health. And a few of the success factors that we picked up in the application and in our work with Robert. You know, when you're looking to get into this game, having a pilot is such a strong best practice. We see this in so many places, even if you have a large portfolio, starting with a single building to hone your approach to data management and organizing your people around the tool, etc., is so valuable. It's not a quick hit. It's a good investment of time and really is worthwhile. Having remote monitoring center with 2 full-time engineers, different organizations do things differently. Some really focus on building their internal staff capabilities if they're of a certain size and have what they think are good enough capabilities. In other cases, there are remote centers that really provide great support and a lot of scalability and a lot of flexibility. And we've seen that success here with the University of Utah Health. And then again, coming to the process, weekly FDD meetings and reports to track progress in finding and resolving faults. Now, we don't say that weekly is better than monthly and better than daily, but the point is that your people are oriented around this schedule that's a regular, and the tool is used to support that schedule. So congratulations to the University of Utah Health. And I'll make one general point here. Some of the numbers you'll see on these quick facts slides represent the participants' engagement with us, the data we've had the insight into, and our own methods for analyzing that data. So in cases where some of the numbers don't quite add up in terms of what we say are the quick facts and what they're presenting, it may be that they've moved on, they're expanding, they have their own internal reporting processes. So I just want to make sure if anyone spots any anomalies there, that's the reason for that. With that, I will hand off to Robert.
Thanks, Elliot. Can you hear me okay?
Yep, loud and clear.
Okay. So University of Utah Health is extremely excited to be receiving this award for fault detection and diagnostics in a new installation. Thank you to the campaign for your consideration, and also to the other awardees. We have 925,000 square feet of connected hospital buildings. We were considering, we were looking at doing a chilled water retro commissioning aimed at reducing our winter chilled water consumption in these buildings. And so this was a good opportunity for us to take a look at analytics and see how we liked it as a retro commissioning tool. And so I'm going to get to that pilot project in a moment. But once we decided that, this pilot was successful, we also had some other really exciting things going on at the hospital campus right now. We have a brand new acute care hospital that's now open on one side of our main hospital, and then a rehabilitation hospital that is opening this month, actually, on the other side of our main hospital. We knew that these two buildings were going to be using analytics in the commissioning process. And so we were able to combine 3 different efforts into one much bigger points package than we otherwise would have got, if we had 3 separate projects. And so that allowed us to have a lot of extra points that we could apply towards, future deployment at our neuropsychiatric hospital, along with 10 community clinics, which we'll be looking at in the coming years. Next slide, please. And so this slide really illustrates how we used the software in the retro commissioning process. We were heavily focused on the Historian app. And so for me as an energy manager, instead of coming in and looking at a list of faults every day, I actually come in and I look at air handler by air handler, the consumption pattern and historical trends. And so this graphic really illustrates what we're looking at here is the chilled water valve command. And we can see, in various phases of the retro commissioning that we were really able to move the needle on our reducing our chilled water consumption. There was a whole winter there in 2018 where we never got below 60%, the valve being 60% open. And then with our retro commissioning efforts, we were able to reduce that down to, what you'd like to see in the middle of winter, which is, next to no consumption for chilled water. And so this is how we're using this tool. One thing is to look at the impact that our retro commissioning efforts are having on energy usage. Next slide, please. So this would be another graph. So this is an air handler that's already been commissioned. We're looking at the same thing. We're looking at chilled water, the percent of the valve being open. And this particular air handler, for whatever reason, in the middle of January, decided that it wanted to open its valve 50%, on a Friday. And so when I came in as an energy manager on Monday and looked at this, I saw, well, something's not right there. We shouldn't be, using this chilled water right now. And so this is, we got our energy team together and looked at this, got it corrected by Tuesday. And so this would be one other big, thing that we used analytics for, is to ensure that after our equipment has been retro commissioned, that it doesn't drift away from optimal performance. And we need to make sure that our initial investment in that, that those energy savings persist over time, and that we don't have a piece of equipment that kind of goes rogue on us. Next slide, please. And so this slide here is an example of really what we want to see out of every air handler. This is an air handler that we retro-commissioned in October of 2018. And this is really, we've now established a new baseline for this air handler with, new sequencing. This is exactly what we want to see is no chilled water consumption during the winter. And, it doesn't even get above 20% of the valve being open, even in the summertime. And so I think that we're able to really accomplish, having every air handler look like this by using this, constant monitoring process with the analytics software. Next slide, please. So these are the lessons learned. If I had it to do all over again, I would start with the meters. We have a situation where our meters were owned by main campus and maintained by them. And it was just a constant battle to keep the meters in good repair and keeping the data, doing an M&V on a retro commissioning project is very difficult if you don't have good meter data. As Elliot mentioned, we found it very helpful to do a pilot on a small scale. We had a 200,000 square foot building that we did a pilot on. And we actually had quite a few bugs to work out, related to tagging, and related to some equipment upgrades. We had a situation where we lost a whole bunch of programming because the JACE crashed, and that's the JACE that we were sucking data from, and so we kind of had to start all over again. That brings me to my next point, which is if you are doing JACE or BAS upgrades, make sure that it would be helpful to do those before you deploy your analytics software. My last two bullet points are what I really, Elliot mentioned. I consider one of the biggest reason for our success, which is an energy committee that meets weekly, and we go over the deployment of the analytics, and then assign action items. The controls contractor and third-party engineer, having them in these meetings was particularly very helpful. Next slide, please. And so just briefly looking ahead, we finally got a meter maintenance program in place. So now we'll be looking at using this software for EMIS, looking at our energy consumption building by building in real time. We're forming an energy dashboard, similar to what we've seen from the other awardees here. We'll be looking forward to doing FDD rules, prioritizing our sparks based on meter data. And we've already mentioned, future deployment in many more clinics. So we're very excited about where this is headed. I have a question here. Do you want me to take questions now, Elliot?
I'd prefer just to save them off to the end here, please, Robert.
Okay. That's my last slide. Thank you.
Okay. Thanks so much, Robert. Moving on to our fourth presenter here, I want to applaud all the presenters for keeping things tight. There's so much to say, but keeping things to about 8 minutes. If we get that here, then we have almost 10 minutes of questions at the end here. So recognizing Pomona College for innovation using EMIS, we have Dodie Hage, the energy manager from Pomona College. And in key success factors we saw here, that they're using their EMIS in a very innovative way as a cloud-based control system overlay. They're exploring the use of Wi-Fi load as a proxy for occupancy. I think having occupancy data is certainly a really useful input for energy management, and the Wi-Fi load piece is part of their exploration of that. And they're using EMIS to perform M&V for energy projects and retro commissioning. And on the slide here, the energy savings of 19% has an asterisk there just to note that we couldn't really tease out the benefits of the EMIS from retro commissioning that happened concurrent. It's certainly a recommended best practice, but the STAR is not any way to reduce the impact of that, but just to note that there's a combination there to get that fantastic savings number. With that, I will hand off to Dodi.
Thank you, Elliot. Just some background information. This is a California Energy Commission grant, and it was in collaboration between Pomona College, Lawrence Berkeley National Labs, Melrock Energy, and the ZeroNet Energy Alliance. Next slide, please. So why would the California Energy Commission fund such a project? Well, I mean, the bottom line is that buildings drift from the moment they are commissioned. And when they do, then they become less efficient. And there are a number of reasons why that typically happens. And one main reason is that I think no one is even looking at the data. And the fact that sensors, actuators, they fail. You have other issues like poor sequence of operation. And then some buildings are not even commissioned in the first place. And so what you end up with is a disconnect between the building design intent and operations and maintenance. And so there was a requirement for, for energy efficiency and optimization to actively and in real time manage and optimize building energy management systems. And this is really what this grant is all about. And given the amount of level of effort, manual level of effort that's required to properly manage a building management energy system, any help that you can get from automated processes is a big, big positive. Next slide, please. And so, but in order to do that, in order to have an EMIS that can sit on top of the BEMS, the Building Energy Management System, you have to cross a couple of chasms. One is that you have to cross the data chasm. How do you connect to a number of energy meters, sub-meters, building management system, many of which are even proprietary. And then the second one is how do you then effect a positive change via controls? And so that would be the control chasm. Next one, please. And the heart and soul of a system like this is really a gateway that's able to connect directly to meters, sub-meters, and BEMS controllers. And the trick here is to be able to read and write. Now with our buildings, the majority of the buildings had proprietary Infinet. And so you could not read and write to them. And so we had to map them from proprietary Infinet to BACnet. And the gateway will go ahead and actually manage information from the cloud. So from the BEMS to the cloud, from the cloud to the BEMS. And it's optimized by engineers and others that will optimize the flow of that data, and that would enable, would enable us to cross both the data chasm and the control chasm. And so we're able to read and write to objects within the BEMS controllers. Next slide, please. And what you end up with is an out-of-the-box system where you can use a lot of data science tools. You can do exploratory data analysis. Like in this example, for example, I'm showing an air handler and its associated VAVs. I'm looking at velocity pressure. I'm looking at the air handler supply static pressure, and a number of out-of-the-box statistical tools like box plots. Box plots are phenomenal tools for looking at a number of VAVs, especially when it comes to velocity pressure. Next slide, please. And another thing is you have a sensor anomaly page. Again, this is all out of the box. This is a list of faulty sensors and actuators. You can filter by issue. For example, here I've filtered by short cycling. I'm looking for all sensors that are short cycling, all command that's short cycling. And then this one is the bread and butter for turning in work orders. I rely on this page heavily to turn in work orders. And to be honest is, you know, if our HVAC crew just simply access this page and turn these into work orders, that's already leaps and bounds beyond anything that we had prior to this. Next page, next slide, please. Similarly, there's a system anomaly page. This is again where you're looking at a system, not just the sensor or the actuator. And in here, like one example would be simultaneous heating and cooling, and we had a ton of that stuff. And so again, here we turn them into work orders, and we go in and we change the programming, or we do whatever we need to do, fix actuators, fix sensors to get our buildings to be running more efficiently. Next slide, please. In addition to active and passive fault detection and diagnostics and root cause analysis, we also, a big part of this grant was then to feedback and effect a change, a positive change, hopefully, and to go ahead and correct for any anomalies. In this example, I'm showing the effect of echo-BEMS versus pre-echo-BEMS. In the top trend, I have an air handler, supply air sensor static pressure. And in the solid line, I have that air handler being controlled by echo-BEMS from the cloud. And in the dashed line, I have pre-echo-BEMS. In other words, no connection to the cloud, and it's just running based on local controls. And the difference is that in pre-echo-BEMS, you know, this air handler is running at 1.2 inches water column, and post, in, you know, during echo-BEMS, it's running at 0.5. And of course, you normalize for downstream data and everything else. And one of the big reasons is that echo-BEMS, the cloud, is looking at a number of variables, including, you know, how the VAVs are doing, downstream VAVs, outside ambient temperatures, and many other variables. And what that translates to is the bottom trend, where we're looking at the KW. This is an air handler that's sub-metered. And what we're seeing is, again, in the solid line, this air handler is running at 2.5 kW versus before it was running at about 7.5 kW. So the energy savings are significant. Next slide, please. And in addition to fault detection, in addition to controls, there's also a Python sandbox that comes with this echo-BEMS platform. And this is very, very important for customization. I've used Python heavily. Python is a very popular data science tool, and many data scientists depend on this. And what this enables us to do is to customize anything and everything. This is a Jupyter notebook that's actually that has direct access in the backend. It has direct access to the data from the Merock platform. And this is a server that's sitting on the Merock platform. And this is an example where we had a brand new building, and I worked closely with our commissioning agent. He gave me the rules as an Excel spreadsheet, and I took those rules and I programmed them into the Jupyter notebook. And this is showing rule number 1, where our commissioning agent was interested to make sure that the actual chill water supply temperature set point stayed within the min and max range. And so we've used this heavily for this type of application, other applications, machine learning, anything else that requires customization and not an out-of-the-box solution. Next slide, please. And so realistically, I mean, when you automate a lot of processes that will help you either guide or directly control BEMS, what you end up with is you get closer and closer and closer to the building design intent. It is possible to run and operate, maintain buildings so that they do reflect the original design intent. And that was it. Thank you very much, Elliot.
Thanks so much, Dodi. And thanks to all the presenters, and great kudos to all of you for your efforts. And we love to recognize the great work that you're doing here. So we're going to move now to the Q&A portion. We have around about 5 minutes. It's never enough, but boy, there was some really great presentation material there. I need to kind of marshal the comments here a little bit, but I'm going to jump in here, which is great, it's topical. So for buildings that are truly unoccupied for COVID-19, is there a new normal in terms of baseload or setback strategy? We don't see buildings that are truly able to shut down entirely. Now there's a lot of depth that can be gone into there, but maybe I'll just broaden it a little bit and just ask about how you see your EMAS supporting you both in going into the shutdown period for COVID and how you expect it to help you as you come out. And I'll start with, let's see, go to Commonwealth to ask that question first.
Sure, yeah, I think that's a great question. And for us in Class A office buildings, we are not truly 100% empty anywhere. We have critical IT staff for tenants still coming in. Some are banks and financial institutions. So we're at 5% of the occupancy we were beforehand. So to us, it's key that the building still has to be running, still meeting comfort criteria, but also managing expectations of tenants, thinking that with only 5% of people in the building that we're going to have 95% energy reduction, which we all know isn't the case. So for us, I think really being able to trend it, keep an eye on individual buildings, but also to be able to compare to our peers and say, look, this is what everyone else is doing, so that when tenants are getting their expense reconciliations, that they don't, that we have backup, but that, you know, we're doing what exactly every other building is doing, and being prudent managers, but we aren't able to cut back to the 5 or 10% power consumption like our occupancy reflects.
Great, thanks. And the same question to Tom at Stony Brook University.
Yeah, thanks, Elliot. Yeah, we really maximize our savings by ensuring the building management system is in fact in unoccupied mode for the buildings that we can close. For some of the buildings that we couldn't close, we squeezed the occupied unoccupied schedule. So instead of it opening up at say 7, we would open up at 8 and close it at say 4:30 instead of 10 o'clock. So we just made sure that by looking at the energy data, we maximize savings. And then the other thing that we do is we just we've been able to baseload buildings now, especially the ones that are totally unoccupied. So that's where it's been helpful, and gathering all the savings and presenting to upper management. As David said earlier, we're hurting economically, so they want to get savings anywhere they can, and now we can prove that we do have savings.
Great, thanks, Tom. And the same question to Robert, University of Utah Health.
So we we actually don't have any shutdowns related to COVID-19. Right. We're actually we have the opposite effect, which is that we have gone to 100% outside air in most of our buildings. You know, in order to mitigate or reduce the risk of airborne transmission within the hospital. And so that, you know, that's something that I'm looking at right now is how we can use our analytics, you know, just to monitor and keep track of, especially as the weather warms up here, how that is going to impact us if we have to stay, you know, at 100% outside air for all of these buildings.
Thanks, Robert. And we're almost at 1 minute, just about 1 minute from time. So maybe a quick answer from Dodi, and then I have to move swiftly to wrap up here. Go ahead, Dodi.
Sure. So one of the things that I found is that even if you turn off a building, even if you go to unoccupied mode, you still have a lot of equipment running, like pumps and other things. And so use the EMIS to flag those and then make some corrections to the sequence of operation.
Great. Thanks for the quick answer there. I wish we had another 30 minutes for questions. I saw a lot of really good questions. Got me thinking about possibly there's a blog that we can get from this just to close out some of those, because I think we always wish we had a bit more time to talk through these. But on that topic, for anyone who wants to become a member of the Better Buildings EMAS technical team, you can continue having these kinds of interactions with your peers, learning these kind of stories, and hopefully having a bit more time in the Q&A for these things. So I want to thank, again, all the presenters, David Nemso from DOE for his introduction, for everyone on the team here who worked on the preparation for this webinar, and now you can go and check the virtual Better Buildings Summit. So thanks all for your attendance today.